Mr. Watson here, and in the final video of this series we're going to look at food/fuel use and its relation to improving aerobic capacity. Now, first thing I'd like to say, with the food and fuel use, it does link to energy systems, and we will be covering energy systems in detail later in the syllabus. So what this is going to look at is when we are working aerobically, what food/fuel are we using, and what does this depend on? So obviously the main fuels we're going to discuss today are carbohydrates and fats. Now these are stored in the body as glycogen and triglycerides, okay? But depending on which one we use depends on the intensity of the exercise and the duration of the exercise. So how hard is the training and how long is the training last? That's going to depend on the fuel you use. So let's take a look at our first graph. So we have intensity versus fuel source. So as we can see, as the graph is still, at lower intensities, fats are the preferred choice of fuel for exercising. So at lower intensities, we're going to use more fat and less carbohydrates. However, as you can see now, as the intensity increases, we use less fat. So this is an example of a VO2 max test. And as we know, VO2 max test could be the direct gas analysis. This is an exhaustive test. So it takes you to your maximal performance, therefore the intensity increases. Okay, so at the start of that, where the intensity is lower, we'll be using a higher percentage of fat, and as you can see, up to around 60%. And as the intensity of the test increases, so does the amount of fat we are utilizing, and carbohydrates takes over as the intensity increases. So what you can see here is the crossover concept. This is when the intensity is approaching your maximal fat oxidation. So this can occur between 45 to 65% of the VO2 max, okay? So there's about a 20% difference there. So usually trained individuals are going to be getting up to 65% of their VO2 max before the crossover concept occurs, okay? Because they have more resistance to fatigue and therefore can utilize fat more, okay? However, an untrained individual may experience the crossover concept a lot earlier due to being untrained. But that's basically what happens is, as the intensity of exercise increases, the fuel that we utilize changes from fat to carbohydrate. So carbohydrate is used at higher intensity exercise and fats at lower intensity. Okay, so that is intensity and fuel source. Now let's take a look at duration. At the bottom there, we can see where I got the graph and how it works. So we'll look at duration. Now, as you can see here, okay, and it's important to note with duration, this graph is based on prolonged low intensity exercise. Low intensity being the key there, okay? So as you can see at the start, it's close to a 50-50 split of using carbohydrates or fats, okay? It's quite a 50-50 split, and that would probably change on the training status of the individual. But as you can see, in prolonged low intensity exercise, as the duration of the exercise gets longer, we start to utilize more fat. Fats become the preferred fuel for longer duration exercise, and carbohydrates drop. Okay, so that's the relationship between these two. The longer you're exercising, the more fat that is going to metabolize and the more fat you're going to utilize, okay, and carbohydrates will drop. Okay, so that's simply how that works. And then got an adaptation of fuel use. So this is a difference here between trained individuals and untrained individuals. Okay, and this adaptation is called glycogen sparing. So this is an adaptation for someone who's undertaken sustained aerobic training. So those that have completed a minimum of 12 weeks of aerobic training. Okay, so what this does, this adaptation is about, and as you can see from the graph, trained individuals can utilize fats earlier in training for longer. So as we can see in the first bar chart, the light moderate of untrained. Now that's very similar to the start of our graph on duration. It's around a 50-50 split. Okay, but that can change if you're trained. You can utilize a lot more fat, and therefore what it means is you conserve your glycogen stores. You save them for when the high intensity, or for when the intensity increases in the exercise. Okay, so just to repeat, in trained individuals there's a higher proportion of fat being utilized, and then in the last bar there you can see carbohydrate is released for higher intensity exercise. Okay, so that's just showing you the adaptation of glycogen sparing and how you can utilize fats more and save your glycogen if you are trained. Okay, so this has just been a little intro into the fuels we use during aerobic exercise. Thank you. What a ledge.